So we're going to work through this example of finding dy dx at the point square root of 2, negative 1 over the square root of 2 for the graph x squared plus 4y squared equals 4. And so that's the equation of an ellipse. And so we have to use, we don't have to, but it's going to be best to use implicit differentiation. That way we don't have to solve multiple equations to figure out which graph of y to use. And so if we go through the steps of implicit differentiation, here's my function, x squared plus 4y squared equals positive 4. And so the first thing we're going to do is we take the derivative with respect to x to both sides. And so we'll get d dx of x squared plus 4y squared equals d dx of 4. And so remembering that anytime we take the derivative with respect to x of a piece of the graph that has an x in it, right, we just take the derivative of it. So d dx of x squared is just going to give me 2x. And then when I take the derivative of 4y squared, I have to remember that I need to include dy dx after I take the derivative of 4y squared. And so the derivative of 4y squared is going to give me an 8y, and then a dy dx to follow. All right, so that's the rate of change of y with respect to x. And that's going to equal the derivative of 4 with respect to x, and that's just 0. Step 2 was to get your dy dx's on one side, and then everything else to the right side. And so we'll be left with 8y dy dx equals negative 2x. And now we're going to solve for dy dx. In some problems, you're going to have to factor. This one we don't. We just need to divide by 8. And so we get negative 2x over 8y. And so that's equal to negative x over 4y. And so remember, when we implicitly differentiate, chances are we're going to get an expression that has x and y's in it. And so dy dx at our point, we're going to just plug in those points now. And so we're going to have negative square root of 2 over 4 times negative 1 over the square root of 2. And so when we simplify that, we're going to get a result of 1/2. And so the slope of the tangent of this ellipse at the point square root of 2, negative 1 over the square root of 2 is 1/2. So let's look at another one. Let's make this one a little bit more challenging. And so let's say our equation is y minus 3 squared plus 4x to the third equals 3y. And so if you want to try this one, pause it, see how you're doing, then click play to see how we go through there. All right, and so I'll use blue. We're going to take the derivative of both sides with respect to x. And so on the left side here, I'm going to get 2y minus 3. So that's using the chain rule, times the derivative of the inside with respect to x, which is going to be dy dx, plus the derivative of 4x to the third is 12x squared. And that's going to equal 3 dy dx. And so if I look here, our next step is to get dy dx by itself. So we're going to get 2 times y minus 3 dy dx minus 3 dy dx equals negative 12x squared. And so I'm going to factor my dy dx's out, because again, that's our goal. We want to solve for dy dx times, we're going to get 2y minus 3 minus 3, and that's going to equal negative 12x squared. And so now that we factored, we're going to be able to get dy dx by itself by dividing. So dy dx equals negative 12x squared over, I'm going to simplify this, so we're going to get 2y minus negative 6, negative 9. And so the rule that will give us the slope of the tangent at any point on this graph is given by negative 2x squared divided by 2y minus 9. And so if we knew a point on our graph, right, so yeah, if we knew some point on the graph, we would be able to find the slope of the tangent using this expression, negative 12x squared divided by 2y minus 9.